Yeah, I've started recording, folks. So, guys, let's have a first recap as to what we have discussed yesterday. Can you please come out with some points? Anything that you could remember from yesterday? Anything that you could remember from yesterday? Thank you, Shraddha. We have discussed about the architecture of LoadRunner. We have discussed about the architecture of LoadRunner. Okay, so can you please tell me the components involved in the architecture of LoadRunner? Scripting is done via Vugen. Okay, wonderful. Then the scripts are transferred into the controller. Actual execution of the script happens where? Actual execution of the script happens where? Shiva? Actual execution of the script happens on the LGs. You can have multiple LGs depending on, we have seen the calculations of LGs as well yesterday, and we have even seen the footprint. If you have stayed back and looked at the little experiment that we have done, we have seen the footprint of each virtual user as well, the memory footprint, and finally the analysis. Okay, so this is what we have discussed yesterday, and we have seen the work of each and every component in detail. Okay, so we have understood what is a group in the controller. Okay, and what does a group contains, guys? What does a group contains in the controller? One is the script. Second is what does a group is, what all the things which are there as a part of the group. First is the script, second is the LG, third one is the number of virtual users. Okay, so this is what is groups. Multiple groups make a test scenario. Multiple groups make a test scenario. So this is what it is, guys. So we have done with this yesterday, and we have went through a case study. Okay, hopefully the case study help you understand the exact complete process of performance testing. Okay, now in the interviews, if somebody asks you what did you do as a part of performance testing, I hope the case study will help you to completely understand the step-by-step process of what happens in a real-time project in a performance testing. I hope so. This case study is extremely important. So today, as Shraddha and others wanted it, so we will go with the workload modeling. Okay, popularly called as WLM. Actually, the idea is, I thought I will cover this workload modeling at the later point of time, because we are continuously dealing with the theory and some of the people might get bored. So I thought probably I push this workload modeling concept for the little later time, once the demonstration of Vugen has started. But certain students like Shraddha wanted the workload modeling now. It's a very interesting topic, guys. So I wanted to cover at this point of time. Okay. So yes. Before I proceed further, there is one point which I wanted to reiterate, even though yesterday I have done it. Okay. So we do know that the controller component of LoadRunner has the ability to control multiple load generators. Okay. Controller component has the ability to control the scripts, control the load generators, and control the number of virtual users. But one thing which I wanted you to look at is, each group can have multiple LGs. Okay, let's say one LG capacity is only 200 virtual users. Then, for each group you can have multiple LGs, as you have seen here. Okay, or one LG can be associated. One LG, let's say one LG has a capacity of, let's say, 500 virtual users. One LG can be spread across multiple groups. So this is possible, and this is possible as well, depending upon your capacity of the LG. Okay. So many scripts can have one LG. Yes, Phil, it is possible. Many scripts have, or many groups, instead of saying scripts, I would say groups. Many groups can have the same LG, or each group can have multiple LGs. This is quite possible. Okay, so this is the point where a lot of people get confused and would ask this question to me. So I made sure I added this slide. Okay, so in the interviews you might get this question. So you never know. So it's better you know this kind of concepts. You know this kind of concepts. Okay. So, so guys, now we will do the workload modeling. So let me figure out my slide deck for the workload modeling. As I've told you, usually, I'll skip that to the later point of time. So it will not be in the flow. So I will have to figure out where it is. So just give me a moment until I figure it out. I'm glad you're liking the theory sessions. Okay. So a lot of people will say, oh, too much theory, what is this guy doing? Is this talking about too much theory? 3 days into the course, it's still theory. Yeah, a lot of people think in those lines. So that is the reason why I've pushed this to later point of time, but I'm glad you're liking it. So there you go. That's our workload modeling. So So concentrate here, guys. This is one of the important activity that happens as a part of performance test. What did I do? Come on. So Phil has a comment. Let's say I think that if you add multiple LGs to one group, the controller will figure out the resource limits. Yes, Phil. The controller will automatically do that. Let's not worry about it. It is smart enough to figure out, to break it down, to see how much it has to burden each LG. I have seen that clearly. Okay, I've done the experiment on that as well. So it is little smarter. It is little smart enough to break down the users. Okay, and see how it is how it has to do that. Okay, yeah. So let's get into this workload modeling. Very popularly call it as WLM. Extremely important activity. So in the case study, you would have understood that there are two things which comes out of workload modeling sheet. Each group, how many users needs to be run. Each group needs to be run with how many users. That information we need it, and the pacing. Okay, the pacing. Okay, so couple of days back, I think we have discussed, couple of days back when we were discussing about the NFR, we have discussed about the significance of workload modeling. Okay, sorry. Okay, so before proceeding further, let's say Phil has a question. So Phil, I didn't get that question. I thought I have answered the question. You can unmute and you can answer the question. Sorry, you can ask the question because I thought I have answered that question, Phil. So you're talking about the load distribution across the LGs.
Hi. Yes. Where do you get the load distribution? No, not across the LGs, but across the scripts to make the full 100% group load.
Okay. So is this question related to LGs or workload modeling? I wanted to understand.
Oh, I'm sorry. Yes, it was related to the workload modeling.
Okay.
I meant to ask earlier.
Okay. So you will understand that now. We will do the calculations. Okay. How do we distribute it across the multiple groups? We'll certainly understand that. So just give me some time. By the end of the class, you will understand that, Phil. Certainly. Yep. Okay, so usually as a part of NFRs, they will give you as to what is the concurrent user load for the whole test. They don't break it down across each group. So as a part of workload modeling, we would have to break it down. Okay, we'll see how the breakdown happens. Is that okay, Phil? Is that okay with you? Yeah. That activity we are trying to do this now. Okay, the same activity or the question that you're asking me, that is the same activity that we are about to do now. Okay, yes. So thanks, Phil. So let's proceed further. Let's proceed further. Okay, so first let's have a first recap, guys. Let's have a recap. Okay, now if you remember, probably maybe at the starting of, I think ending of the last week. Okay, so probably this was on, in India it was Friday, I believe. Yeah, this is when we have discussed about this. So everybody remember this we have collected as a part of NFR gathering. We have collected this information. Okay, let's say this is the business critical transactions. Okay, let's go through, and we have assumed this is a banking application. Let's say it's a banking application, and we have only 5 business critical transactions. Okay, so one, which is login, account summary details, transaction history. Okay, open FD. Okay, so in India we call it as FD, in US you call it as CD. Okay, and statement for the last 5 years. Let's say these are our performance critical business transactions. Okay, and now as a part of the gathering, as a part of NFR gathering, we have collected all this information, and we have discussed this in detail as well as to how to collect this. Okay, how to collect this, we have discussed that in detail as well. Okay, and here also we have understood the type of the critical transaction. You see login, so it is a high volume transaction, that is why we have collected this. Okay, account summary details, again high volume. Okay, checking transaction history, again it is because it's a high volume, we have considered it as a performance critical transaction. Then FD and statement. Okay, so this is all we have understood as a part of NFR gathering. We have collected this information. So everybody could remember this, guys? Everybody could remember this? All of you? All of you? Yeah, this is, we have spent almost 1 day understanding this particular thing. Okay, if you remember. Okay, so how do we get this? We get this from the client. Okay, we get this as a part of performance critical transactions, and for each performance critical transaction, the transactional volumes, we will get it from the client. If the client is not giving it to you, you can go to the web server logs, request for the web server logs, and then you can get this information. Okay, so there is a there are certain tools using which you can actually get this breakdown. So we have understood all this information, we have clearly understood this. Okay, now using this information, we'll do an activity called workload modeling. Okay, so if the client is giving it to you, it's fine. Otherwise, the tools like Splunk can help you pull out the from the real-time data. It will help you to get this information. We have discussed all this in my previous classes. Now we'll do the workload modeling. Okay, we'll do the workload modeling, guys. Okay. Okay, so to understand, again, to understand, this is the initial NFR. Now we'll do the workload modeling for this, but let me build it up. Let's understand the workload modeling from the scratch. For that, I'm taking some small numbers. Okay, so we'll start building it up slowly, step by step, and finally we'll do the workload modeling for this NFR. Okay, finally by the end of this class, we'll do the workload modeling for this NFR. But right now, let's just try to understand, let's try to build up, okay, slowly taking a small data, okay, and then we'll do the workload modeling for that, and then we'll slowly build up, and then we'll finally do the workload modeling for our initial setup, okay. So now let's assume, okay, these are the numbers that you have collected. Just an assumption, guys. Just an assumption. Okay. How many transactions, how many business processes are there? There are only 4. Login, account summary details, transaction history, and open FD or CD. Okay. So that I can explain, I have taken minimum numbers. But in the real-time projects, how the numbers will be like? The numbers will be in terms of hundreds like this. Okay, in terms of hundreds like this, the transactional volumes. What is our agenda? To do the workload modeling for this particular assignment, or for this particular NFR. Okay, that is our final agenda. But so that I can explain, I've started with these minimum numbers. What is that? Login, only 6 transactions per hour happening per hour. Account summary details, only 5 transactions. Checking transaction history, only 4 of them. And open FD or CD, only 1 of them. Okay, let's assume this is your NFR. Okay, it's just an assumption, guys, so that I can explain the concept. Okay, Now let's do the workload modeling only for the first business process, which is the login business process. Okay, so we'll do the workload modeling only for the first one, which is the login one. Okay, only for the first one, which is the login one. Hang on, guys. Some of the people are facing the issue, not issue. No, I'm not. Have we joined the right meeting link, guys? I'm just trying to understand. So we have joined the right meeting link. Then why are the students are facing these issues? So anybody faced any issue joining, guys? Anybody faced any issue? No. So why I'm getting so many messages? So many students are not able to join. I'm surprised. Okay. Sorry about that, guys. Sorry about that. Okay. Now, okay. So what is that? What is that? We are trying to do the workload modeling for the first business process, which is the login business process. Once we understand how to do the workload modeling for the first one, we know how to do it for the second one, the third one, and fourth one, or how many of them are there. We will be able to do it for all of them. Okay, let's try to understand, slowly build it up, concepts like, with a smaller concept, and slowly we'll build it up, and we'll go to the bigger numbers as well. Okay, so now we are trying to do the workload modeling only for the first business process, which is the login. Okay, what is the first thing? What is the first thing the performance tester would do? He will create the login script. Okay, he will create the login script. Okay, what is the? So he will create the login script. Hang on, guys. So 1 second. Please restart the system and try again. Okay. So now what does the performance tester would do? He will create a login script. Okay. He will create a login script. Okay. He will create a login script. Now let's observe clearly what is there in the login script. Let's observe very clearly what is there in the login script. Okay. So you would have something called a launch transaction. Okay, without launching you will not be able to log in, guys. Without launching, you will not be able to log in. This is something that everybody knows. First, you need to launch the page, then you will enter the username and password and click on the login button. So definitely you would have to have the launch transaction. So you have a launch transaction, then you have the think time. We've already discussed this. Between every two transactions, there is a wait time, which we call it as a think time. So there is a think time. Then again you will have the login transaction. Then you have a think time, and then finally you have a log off transaction. You have a log off transaction. Okay. So in the login script, do we have only one transaction? Do we have only one transaction? No, we have three transactions: launch transaction, login transaction, and log off transaction. Okay. Hang on, guys, 1 second, please. I'm having some issues today. Just give me 1 moment, please. Sorry about all the delay. So okay guys, now as you see in the login script, okay, so yeah, Phil, I'll take that question. Phil, I'll take that question, but let me come to the logical ending of this. I'll certainly take that question, Phil. So yes, so we have a launch transaction, then we have a think time, we have a login transaction, then we have a think time and a log off transaction. Okay, so this is our login script. So on a careful observation as to on the login script, we have understood that it's not one transaction, but it has 3 transactions, and there is a think time between every single transaction. Let's say the overall execution of this complete script, which includes 3 transactions and 2 think times, just for our discussion purposes, let's say it is 10 minutes. How much time is it? Let's say it is 10 minutes. Okay, let's keep these facts aside. Now, what is the NFR that the client has given? If you go back to the slide deck, what is the NFR that the client has given? We need 6 logins. Shraddha, how many logins we need? We need 6 logins. Okay, we need 6 logins. Okay, so as part of the NFRs, this is not something which I have cooked it up. Okay, so client has provided this NFR. What is that? 6 login transaction needs per every single hour. Okay, now as I've told you, performance tester has created the scripts, this login script. Okay, and we have just understood that, or we have assumed that for the complete execution of login script, which includes 3 transactions and 2 think times, it has taken 10 minutes. How much time it has taken? 10 minutes. How much time it has taken? 10 minutes. Okay. Now, we already know usually a load test will be run for how many hours? 1 hour. This is something which we have been discussing from the last 3 weeks. Okay. Load test would run for how many hours? 1 hour. Okay. Now, I'll give you a couple of approaches. I'll tell you a couple of approaches. So please tell me which approach, if you were you, which approach you would do. Okay. Okay. So hang on guys, as a student who is continuously facing the issue, not sure why it is. So it is straightforward. I think she is using the wrong link. So guys, please try to join 5 minutes upfront early, so that I'll be able to help you. Otherwise, once the class starts, it becomes so difficult for me to help you guys because I have to stop the class. So is the session meeting ID ending with 5565 guys? Session meeting ID ending with 5565. Can somebody please confirm our meeting? Yeah, it is 5565. Yes. Yeah. Thank you, Shraddha. So try to join 5 minutes upfront early, guys. If there are any issues, I'll be able to solve it. Otherwise, in the middle of the class, it becomes so difficult. Oh, finally, Susie has joined. Okay. Now you see, approach 1. Okay. Carefully observe this. What is our agenda? There are 6 login transactions which we need to accomplish. Are we doing it because we wanted it? No, the client wanted us to do it. In that 1 hour, he wants 6 logins to be done. Okay. Now you see, approach 1, first virtual user. You have taken the virtual user 1. Okay. He has executed the login script. Which contains 3 transactions and 2 think times. Okay. And the remaining time, how much time will be left? You are running the test for 1 hour, right? You are running the test for how many hours? 1 hour. So in this whole 1 hour, 10 minutes went into the execution of the script. Okay. What would be the remaining time, guys? 50 minutes. Wonderful. Okay. So in the next 50 minutes, he's not doing anything. Okay. He's not doing anything. Now, the second virtual user. Okay. So second virtual user, again, he has taken the login script. Okay. He's running that login script, which means that, 10 minutes is consumed. Again, the next 50 minutes, he's not doing anything. Okay. So like this, we have taken how many users? 6 users. Okay. 6 users. Each of the user is taking the login script and is running. Okay. So you see, each virtual user is taking the login script and executing the login script. Okay. And executing the login script. So Now 6 users have taken the login script. Each one executed the login script once. Okay, and the sad part is the remaining 50 minutes the virtual user is not doing anything. Okay, so be it. That's not an issue. But this is the 1 hour line, right? This is the 1 hour. You see, the whole test is for 1 hour. Each virtual user has 1 hour. Okay, so each virtual user is taking the login script and executing. Totally 6 virtual users are there. He has taken the 6. They have taken this login script and executing it. So now, how many logins we have accomplished in this 1 hour, guys? Overall, by all the virtual users, how many logins we have accomplished? I want to hear from all of you. Okay, 6 logins. Okay, what is the client wanted? 6 logins transactions per 1 hour, or 6 logins. Okay, 6 logins we wanted it per 1 hour. Okay, now, okay, so wonderful. Okay, so this is my approach 1. This is my what? Approach 1. Okay, so we have accomplished what client wanted us to do. We have accomplished what client wanted us to do. Wonderful. Okay, now whatever client wanted us to do, we have done. We have taken care of that. Okay, our NFR is met. Our NFR is met. We have whatever the load that we are supposed to accomplish, we have accomplished it. Perfectly fine. Wonderful. Now I'll give you the approach 2. I'll give you the approach 2. Okay, virtual user 1. Okay, see what happened. He has taken the login script. Which means that it will take 10 minutes. Okay, once the entire script is done, he's not keeping quiet for the next 50 minutes. He's immediately running the second iteration. Second iteration means he will take the same login script and he will execute once more. So he's executing once more. That's the second iteration. You go to any dance or something like that, you go to any place, okay, any dance shows or something like that. If you like somebody's show, right, you would say once more. Similarly, okay, the user, what he has done, he has executed the login script. Okay, he has executed the login script, and he knows he has the 50 minutes left. So why he should keep quiet? He thought, I'll take the login script again and then I'll execute once more. Okay, so then once more, and once more. Okay, so you see, each iteration is 10 minutes. So 10 minutes plus 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 10 minutes, overall 60 minutes. So this one is the login script, again the login script, again the login script, and then again and again. So how many logins we have accomplished in this one hour in this approach 2? How many logins we have accomplished in this approach 2? So 6 logins. Okay, client wanted 6, we have got 6. Approach 1 also we have got 6. Approach 2 also we have got 6. Okay, so both, by doing each of those approaches, we are accomplishing what the client wanted us to do. So both the approaches are right. There's nothing right, nothing wrong. But performance testers, and you know that in each iteration what is there. Okay, launch transaction, think time, login transaction, think time, and log off transaction. Okay, we know what is there in each iteration. Okay, so keeping these facts intact, now having known that both the approaches we are accomplishing the NFRs, okay, which approach is good, or which approach do you think will be followed by the performance testers? Okay, I want to hear from all of you guys. Approach 1 or approach 2? Approach 1 or approach 2? Okay, and before answering, there is one more fact I would like to give you. Okay, one more fact that I would like to give you. When we purchase the tool, any performance testing tool, you are purchasing what? Virtual users, not controller, not VUgen, not analysis. Every virtual user is precious. Okay, every virtual user is important. You have to put money for the virtual users. It's expensive. Okay, so having kept that fact in mind, okay, so which approach would you like to go to? Approach 1 or approach 2? I want to hear from all of you guys. Okay, so okay, wonderful. So most of you are saying approach 2. Okay, so yeah, so the least expensive one. Okay, so Melly, the question is, okay, which approach would you go with? With both the approaches, we are accomplishing what client wanted us to accomplish, which is 6 logins per hour. So I'm just wondering, if you were the performance tester, which approach do you take? Approach 1, wherein you will take 6 virtual users for 6 logins, or 1 virtual user for all the 6 of them? Which one would you go with? Okay, so some of them are saying 1, or some of them are saying 2, but typically it is the second approach which most of the people would go with. Okay, wherein you're getting the work done with the least number of virtual users. You're getting the work done with the least number of virtual users. Okay, so typically this is what usually people go with, but there are other facts we have to keep in mind as to, like, what needs to be done, but we'll get to that facts. Okay, we'll get to that facts, but right now just assume that approach 2 is what a lot of people would go with. Okay, with no with no other restrictions. Okay, considering there are no restrictions, approach 2 is the best approach, because we will be saving the virtual users. We'll be saving the number of virtual users. Okay, wonderful. So wonderful. Now I'll throw one more NFR at you. Let's see what happens. Okay, now client said, oh, no, not 6 login transactions. Okay, I got that. That was a mistake. So it's not 6 login transactions per hour. Client said there are only 3 login transactions per hour that are happening. Okay, that are happening. Now we have decided that we'll go with only 1 virtual user. So I'll take only the 1 virtual user and we'll discuss on that fact. Okay. Now, okay, we know these facts. Performance test usually runs for 1 hour. That is the reason why we gather the NFRs for also 1 hour. Okay. Now you see, performance testers create the login script, and we have assumed that for the whole execution of the login script, it is taking 10 minutes. That's an assumption we have made. Okay. Now again, there are 2 approaches which I'll give you. So let me see what approach would you select. Okay. Approach 1. Okay. We have decided that, it will, whatever is possible with the virtual user one, we'll do it. I mean, we'll take only 1 virtual user and we'll get the work done. We don't need more virtual users. Okay, keeping that fact in mind, now we'll look into 2 approaches. Okay, you see, virtual user 1 has taken the login script and he has executed. So the first iteration is done. Now again, immediately he has taken the login script. Okay, he has executed. The second iteration is done, and he has taken the login script, executed. The third iteration is done. Now, how many we wanted? 3, and we have accomplished 3. So he will not be doing anything for the next 30 minutes. He will not be doing anything for the next 30 minutes. Wonderful, wonderful. This is my approach 1. Now let me give you the approach 2. Let me give you the approach 2. Okay. Now approach 2 is okay. Virtual user 1 takes the login script. Virtual user 1 takes the login script. Okay, takes the login script. He will execute. Okay. Now he will keep quiet, not doing anything for the next 10 minutes. Okay. So he'll keep quiet, not doing anything for the next 10 minutes. Okay. Then he will execute the next iteration. Okay. And he will keep quiet, not doing anything for the next 10 minutes. And he will go with the third one. Okay, and then he will keep quiet, not doing anything for the remaining. Okay, this is my approach 2. Okay, this way also we have accomplished how many iterations? 3 iterations. We have accomplished how many iterations? 3 iterations. Okay, now which approach do you think you should go with? Okay, which approach do you think you should go with? Okay, the first approach wherein you get the work done, all of them together, and then relax for the next 30 minutes, the virtual user. Or the second approach wherein he has evenly distributed the work across 1 hour. He has evenly distributed the work across 1 hour. Which one do you think you should go with? Okay, so as you said, approach 2 is better. Okay, because if in case as a performance tester, you are going with the approach 1, the client will immediately ask, is my load is evenly spread across that 1 hour? Or is my load is evenly paced, or evenly spread across that 1 hour? Okay, so if you're going with approach 1, then your answer will be no, because your load is not spread across completely, properly spread across the whole 1 hour. You're getting your first half an hour, you have the extreme load, and the next half an hour, there is no load. So that's not the right way. You have to put the load across the servers, evenly. So that is possible. That is possible using your approach too. By the way, this wait time between the iterations, there is a specific word for that. What is that called, guys? What is that called? Pacing. What is that called? Pacing. The pacing will allow the script to evenly pace, the load to be evenly paced across the servers, or the script to be evenly paced across that 1 hour. Okay, this is very, very important. Now, lot of people have a doubt here. What is the difference between think time and pacing? Both of them are waiting time. Then what is the difference between think time and pacing? To answer that question, I have included this. Now, you should know 100% what is the difference between think time and pacing. Think time is what? Is the wait time between two different transactions. What is the pacing? Pacing is between two different iterations. Okay, one iteration, you can have any number of think times. But pacing happens between two different iterations. You see, you have a think time, then you have a pacing. Then again you will have a think time, then you will have a pacing. Think time and pacing. Okay, so the waiting time between two different transactions is think time. The waiting time between two different iterations is the pacing time. Now, if you pay a little bit of attention, think time is the simulation of the real user. Okay, is the wait time for the simulation of the real user. But pacing, we are adding this wantedly just to make sure that the iterations are spread across this 1 hour. That there is a standard think time of 10 seconds. There is a standard think time of 10 seconds for all the web applications. Okay, we cannot play around, or we cannot increase, or we cannot decrease. It is a standard time. But pacing, according to the load distribution, pacing could be anything. We have to calculate this. In this case, the pacing is how much? 10 minutes. In this case, the pacing is how much? 10 minutes. Okay, in this case, it is 10 minutes. So, as a performance tester, as a part of workload modeling, you have to calculate this pacing just to make sure that the iterations are evenly spread across that 1 hour. Okay, pacing could be anything. Depending upon the script execution time and how many iterations you wanted to run in that 1 hour. Okay, so performance tester who calculate this pacing depending upon how many iterations you need to run in that 1 hour and what is the script execution time of each iteration. Based on that, you will have this pacing time. The performance tester needs to come out with that number. There is no standard values. There is no industry standard values. As a part of workload modeling, you have to calculate this pacing. Okay. Now, somebody who wants to see me writing so that you will understand, I am writing this. Okay. What is think time, guys? What is think time? The wait time between two different transactions. What is pacing? Both is wait time only. Wait time between two different iterations. Okay, very, very important interview question. Okay, so we have a standard second. This is the first difference. Okay, let's look at the second difference. There is a standard think time of 10 seconds, which is industry standard. This is for web applications. Okay, so there is no standard. Pacing time. We need to calculate. Performance tester will calculate this as part of workload modeling. workload modeling. Okay. Okay. So this is what it is. Okay. This is what it is. This is extremely important. So far it is clear, guys. We haven't learned anything about workload modeling yet. We just started. Okay. We remember what is our agenda. What is the agenda? How we have started the slide. Okay. If you remember, we wanted to do the workload modeling for this NFR. You remember, this is our agenda. By the end of this class, we should be able to do the workload modeling for this particular NFR. Okay. To slowly build it up, we are taking a smaller numbers and we are slowly doing it for one business process so that we can spread that concept across to other business process as well. Okay. Okay. Yes. Yes, Phil. Yes. Okay. Now, so because for the load distribution, exactly, for the load distribution, okay, the pacing is for the load distribution across the complete this thing, okay. Now we'll take the next assignment. The client said, oh, I'm really sorry, Kumar. Initially I said 6, then I said 3, but actually the reality is there are 12 login transactions. Let's assume this is what client said. 12 login transactions per hour that is happening. Okay, then I said, no problem. Okay, let me start my workload modeling. Okay, so you have taken the same login script, you have created the login script. Again, you have realized that for execution it is taking 10 minutes. Okay, now you have started executing without pacing. Zero pacing you have executed. The maximum you can accomplish in 1 hour is how many? Maximum you can accomplish in 1 hour is how many, guys? Okay, without pacing, with zero pacing, without any gap between any 2 iterations, you continue to execute. The maximum you can accomplish in that 1 hour is 6. But what is client asking for? What is client asking for? 12. Now what do we do, guys? What do we do? What do we do? Wonderful, guys, wonderful. This is what I've expected from the class. Add one more virtual user. Add one more virtual user. Add one more virtual user. And the virtual user will continue to execute all the iterations as well. So first virtual user, how many iterations he have accomplished, or how many logins he have accomplished? 6. Second virtual user, how many logins he have accomplished? 6. Total how many? Total how many in that 1 hour? This is my complete 1 hour, right? This is my complete 1 hour, right? This is my complete 1 hour, right? How many? 12 iterations. 12 iterations. Wonderful. 12 iterations. Wonderful. Okay. So now if you have taken the login script and executed in the controller, you could have executed with 2 virtual users. What is the outcome with zero pacing? What is the outcome? The outcome is 12 login transactions. Now this is a concurrency. Now there is a concurrency of 2 virtual users. How many concurrent users are there now? 2 concurrent users. Okay. Is there any issue with the link, guys? I see a lot of people logging off, logging in, logging off, logging in. I just wanted to understand, is this because of the internet issue of those students, or it is because of the GoToMeeting? Okay. There is no issue, right? There's no issue, right? Yeah. I've seen at least 3 students continuously logging off, logging in. Okay. So guys, please check your internet speeds, guys. It's very important. Okay, the concepts that I'm telling you, it's very slowly building up. So if you're logging off and logging in, right, you'll not be able to understand. Yesterday, one of the dear students, Shraddha, has faced this issue as well. So please make sure that you have a good internet speeds. Okay. However, I'll be sending you the recorded videos. I hope the session is getting recorded. Yeah, thank God, session is getting recorded. Yes. So yeah, please make sure that your internet. Okay, so Chaudhary, after the class, stay back. Okay, Chaudhary, I have an issue in Firefox with sounds, but no issue with Chrome. Okay, so stay back. You have to download a plugin which is GoToOpener, so that you never had to deal with the browsers. And one more thing, guys, I have an earnest request for all of you. So when you click on this link and you try to open this link in either Internet Explorer or what is the new browser which is the replacement for Internet Explorer? Internet Explorer or Edge. Yeah. So if you open that in the Edge or Internet Explorer, then it will prompt you to download. It will prompt you to download that plugin and join using that plugin, so that you will not have any issues related to sound or any issues related to you speaking to me. Okay, whatever the link I have given you, copy that link, paste it in the Internet Explorer, then immediately it will ask you if you want it to download. So go ahead and run and download it. Okay, so go ahead and run and download it. By the end of the class, stay back. I'll show you how that works. Okay, but if you're trying to join using the browsers, you will have some issues related to sound and all that. Okay, so after the class, I'll show you. I want everybody to stay back, and tomorrow when you join, you're joining using the GoTo opener, not using any of the browsers. Okay. So in Chrome, it is not prompting for whatever the reason. Either if you paste that on IE or Edge, then it is prompting. Yesterday, I have helped 2 students out. Then I have realized that, yeah, in every browser, it is not prompting. Only certain browsers, it is prompting. Okay. So after the class, stay back. We'll spend 10 minutes on that. So take care of this issue forever. Okay. Now you see, there are 2 users, and how many iterations we have accomplished? 12 iterations. We have accomplished 12 iterations. Okay, we have accomplished 12 iterations. Okay, so we have gotten what we want. Okay, now we will go. Now that we have established this one, we will see how a real NFR looks like. Okay, this is what a real NFR looks like. Okay, they will not only tell you how many transactions needs to be done in 1 hour, but with how many concurrent users as well. So what is that? What is my client saying? I want 6 login transactions per hour with 2 concurrent users. With how many concurrent users? They will also tell you the concurrency as well. How much load needs to be done in 1 hour with how much concurrency. Okay, this is what a real NFR looks like. Okay, 6 login transactions needs to be accomplished in how much time? 6 in 1 hour, but with how many concurrent users? With 2 concurrent users. Okay, let's see. Now you tell me what we should do, guys. Can somebody please tell me? Wonderful, Rahul. We have to include pacing. Because if you don't include pacing, with the first virtual user itself, we can accomplish 6. The second virtual user should just keep quiet. He should not do anything. That's totally incorrect. So now the 6 logins, you have to break it down across 2 virtual users. The first virtual user will take 3, and the second virtual user will take 3 more. Okay, so the first virtual user will execute 3 transactions with the appropriate pacing. Okay, 3 transactions or 3 iterations with the appropriate pacing, and the second virtual user will take the same login script. Again, he will execute 3 iterations with the appropriate pacing. So what is the pacing time here, guys? That is appropriate. 10 minutes. The pacing is 10 minutes. Wonderful. So he will execute the iteration, assuming that this is 10 minutes. The pacing will be 10 minutes. This is 10 minutes. Pacing is 10 minutes. Like this, 3 iterations by the first user, and then 3 iterations by the second user. Now, as a performance tester, we have our agenda is to calculate the pacing. Now the next question is, Kumar, the numbers are very small. This is 6, this is 2. Okay, immediately I know the pacing is 10 minutes. But what if? Okay, so Phil, I'll bundle all your questions together and I will answer, because by the end of this class, most of the questions will be answered, and then if it is not answered, I'll bundle all of them together and I'll answer. I know there are 3 questions pending from you, Phil. Okay, but I'll certainly take all the questions. Okay, because I don't want to break the flow. Okay, I hope you understand. But whatever the questions you are facing, put that in the chat window. Not only Phil, Shraddha, everybody, whoever have the questions, put that in the chat window, all of you. Okay, so if there is something which is appropriate, I'll take it right away so that it will help you. It will help with the flow of the class. If not, I'll put all of them together, bundle it, and explain one by one very carefully. Okay? But don't think that I'm ignoring your questions. No, not at all. I want all the people to be attentive, and I want everybody to ask the questions as well. And some people, like if they have a question in the mind, they cannot keep it. So that's the reason why I'm requesting you to put that in the chat window. But I'll take it at my own pace. Okay? But please do understand that as well. Okay? Okay? Don't get offended that, oh, Kumar is taking someone's question but is not taking my question. No. It depends upon the question that you have placed. I'll see when is the appropriate time to answer, and I will answer. Okay? Okay, Melik, can you run it just with one user and less wait time? No, clearly client has said that we want with two virtual users, right, Melly? So we wanted to use two concurrent users at any cost, because that will add the concurrency. Okay, because performance testing is not just about adding the load, but it is about the concurrency as well. When two scripts are executed at once, we wanted to see how the server is handling that load. Okay. Okay, so yeah, Melly. So I hope I have answered that. Okay, so now you see, since it was 6 login transactions per hour and 2 concurrent users, you were able to do, or you were able to calculate the pacing without any hassles. Okay, but what if the numbers are something like this? 1025 login transactions per hour, which needs to be done by 289 concurrent users. Now how do we do it? You're getting the point, right? Since there are less number of login transactions and less number of concurrent users, you have drawn the picture, you have visualized it, everything, and immediately you said pacing is 10 minutes. Immediately you said pacing is 10 minutes. But if the numbers are something like this, 1025 login transactions and 289, okay? So do you think a formula will help you guys? Do you think a formula will come into handy? Do you think a formula will come into handy? Do you think a formula would help you? Okay, I'm asking you, all of you guys. Do you think a formula would help you? Yes, we need a formula, right? Otherwise, how can you draw 289 lines and break it down 1025 to 289, and then, doing all that is such a pain in the neck. Okay, so this is the reasons why there are formulas, right? Okay, formulas will make your life easy. So we need a formula for this. We need a formula for this, and luckily there is a guy called Little. Okay, there is a guy called Little. Okay, so have you seen this movie, Little? What is that movie? Stuart Little. Stuart Little, yeah. That's one of my favorite movies. Stuart Little. Little Stuart? Yeah, Stuart Little. Yeah, it's one of my favorite movies. So, it's not that little, okay? There's a guy called Little. He came out with a law. What is this law? Little's law. What is the law? Little's law. Okay, so in order to handle these complex numbers like this, okay, which you cannot calculate in your mind, okay, if you wanted, you're really good with math, you could calculate in your mind, but not people are so good, so we needed a formula. So a guy called Little has came out with the formula, okay, and then we'll use that formula. We'll use that formula right now. We'll use that formula right now, okay, but before going and start understanding the formula, okay, I would tell you that Little didn't, okay, created this law for workload modeling so that you could do workload modeling, or he didn't do it for performance testing. He didn't do it for performance testing, or he didn't do it so that you can do the workload modeling. He has created this law for something called closed systems. Okay, he has created this law for something called closed system. There is open systems, there is closed systems. So he has created this law for the closed systems. So we have extended this law which Littles have created for the closed system for our workload model. That's it. Okay, he has created it for some other purpose. So we are using that for our performance testing, for our workload modeling. Okay, but please do understand that he didn't created it for performance testing or workload modeling. In fact, when he has created it, I don't think there was a term called performance testing. I'm just giving it a guess. I don't know, but I don't think there is something called performance testing at all. Okay, so he has created it for something called closed systems. Okay, so there's something called closed systems and open systems. So he's created this for closed systems, and we are extending that law for our workload model, for our performance testing. So we'll take a break of 10 minutes. Once we come back from the break, okay, we'll clearly go through this law, understand the law, define the law, and we will start applying this law for our workload modeling sheet. Okay, expect the class to go for 15 more minutes more. So please stay back. I mean, please prepare your minds that you will be staying for 10 to 15 minutes more. Okay, but today we'll try to complete the workload modeling chapter. We have just started the workload modeling, guys. We haven't even touched the tip of the iceberg yet. Okay, we have just understood. Slowly we are building up. Slowly we are building up so that we will finally get to a point where we will do the workload modeling. Okay, we came to a point to understand why a law or why a formula is important. Okay, so we will define the formula and we will apply this workload modeling for our real sheets. Okay, and then maybe over the weekend we'll see little advanced topics of the different workload modelings. Okay, so that's an agenda. Take a 7-minute break, guys, because as I'm speaking, I've consumed 3 minutes. So we'll take a 7 minutes break, and when we come back, we'll start. All your questions, put that in the chat window. Somebody who has done the workload modeling, whatever I've done, you know, it's a little confusing maybe for you. Put that in the chat window. We'll get to the point. We'll complete the workload modeling, and then we'll take one question after another question. I'm stopping the recording, guys. Okay, and I'm keeping you on mute. But you know, please remind me to start recording once I come back. Let's resume recording. Okay, so can you please confirm if you are able to hear me? Can you please confirm if you are able to hear me? Thank you. So before the break, so guys, before the break, I hope everybody is back. Before the break, we understood that we needed a formula or we needed a law so that our calculations becomes easy. And we are using Little's law. We are using the Little's law for our calculations. Let's understand this Little's law. Okay, how he has come up with this law and all that we'll not understand. We'll just come up with the law and we'll try to understand the law as to how to use the law. Okay. So this is what a Little's law looks like. Okay, Little's law is what n is equal to x multiplied by RT. So how he has come out with this formula, what is the reason behind it, what is the logic behind it? I don't want it to cover that one because that is completely different. As I've told you, this Little's law is for something called a closed systems. Okay, so again I have to explain what is closed systems, open systems, and how exactly he has come out with that formula. Let's not look into all that. Let's only try to understand what this formula is. What is this formula? N stands for what? N stands for number of concurrent users which the client will give us. Okay, X stands for what? Throughput. X stands for what? Throughput. Throughput is what? Transactions per second. What is it? Throughput is what? Transactions per second. Okay. Throughput is what? Transactions per second. Okay. Transactions per second. Okay. I'll come to that. Okay. N is what? Number of concurrent users. Okay. Number of concurrent users. Number of concurrent users is n. Okay, it's a capital N. And throughput X is what? X is what? Throughput. Throughput is what? Transactions per second. RT is what? Response times. RT is what? Response times. So what is this formula? Number of concurrent users is equal to throughput multiplied by response times. Throughput multiplied by response times. Wonderful. Okay. So now, if any system has a think time, this formula can be modified into this particular thing. Okay, the formula can be modified into this particular thing. What is that? N is equal to X multiplied by RT plus ZT. ZT is what? Think time. ZT is what? Think time. Okay, we already have the industry standard time for think time, which is 10 seconds. Okay, so ZT is what? Think time. Okay. Now, what is the modification of the formula? N is equal to throughput. N is equal to throughput multiplied by N is equal to throughput multiplied by RT. Okay. What is RT, guys? What is RT? What is RT? What is RT? I'm asking everybody. What is RT? Okay, RT is response times. Wonderful. RT is response time. ZT is what? Think time. ZT is what? Think time. Okay, wonderful guys, wonderful. So this is the final formula for the closed systems with a system with a response times. This is what a little has come out with. A guy called Little has come out with. Okay, now how we are modifying this particular law, for our workload modeling, watch carefully. Okay, so please mute yourself guys, please mute yourself if you don't have anything to speak, okay, because that kind of disturbing the class. Thank you guys, thank you. Now now I hope I have the slide for this. Yeah, now this is what it is. Okay, what is RT plus ZT? Now this is what the law, this is what the Little's law. Okay, this is what is the Little's law. Now we are modifying the law. Okay, we are adjusting the law, or we are what do you say, consuming this law for our workload modeling. Okay, so let's see how we are modifying. Okay, how we are modifying. The first thing of the modification is RT plus ZT. Okay, response times plus think time is equal to what? Script execution time. Okay, script execution time. How you carefully look at, if you have taken the login script, yeah, that's the right word. Adapting. I'm looking for that word. You know, I have a small vocabulary, so I try to explain with the vocabulary I have. Okay, thank you. I also will adapting this law for our workload modeling. Watch carefully. So why I'm calling this RT plus ZT is a script execution time? Please watch carefully. You know, we have been taking this example of login script, right? In the login script, what we have a launch transaction, think time. Launch transaction means it is a response time, right? This is the response times for the launch transaction. This is the think time. This is the response times for the login transaction, think time. Then you have a response times for logout. If you add all of that, what do you get? Script execution time. For the whole script to execute, you will get the script execution time. Okay, so that is what is RT plus ZT is. Okay, it's a total script execution time which includes how many? 3 transactions and 2 think times. Okay, now what does this formula become? Has become? Now N is equal to X divided by script execution time, SCT. Okay, instead of writing the whole thing, I'm just writing it as SCT. SCT is what? Script execution time. Script execution time. Okay, now this is as a part of adaptation, or we are adapting this law for our workload modeling. What is the first change we have done? N is equal to X multiplied by script execution time. Okay, so but we do know that we have pacing when it comes to performance testing. So the further adaptation is N is equal to X multiplied by script execution time. This time around I will just say SCT plus pacing. This is nothing but the workload. This is nothing but the adaptation of Little's law for our workload modeling. The adaptation of the Little's law for our workload modeling. What is SCT? Script execution time. What is N? N is the number of concurrent users. What is X? X is the throughput, which is transactions per second. Okay, so this is what it is. So this is the adapted version of Little's law for purpose of workload modeling, or for doing workload modeling. Okay, so in case in the interview, if somebody asks you what is Little's law, I would suggest give them the answer this thing. N is equal to what? X multiplied by RT plus ZT. But in continuation to it, you can say that for your workload modeling, you have adapted that particular Little's law so that you will be able to calculate the pacing, and this is what it is. Okay, so right away don't tell them that what is Little's law. right away don't tell them this formula. What is the actual Little's law? What is the guy called Little has came out with the law? The law is N is equal to X multiplied by RT plus ZT, where X is the throughput, RT is the response times, ZT is the think time, and N is the number of concurrent users. This is the Little's law. This is the actual Little's law. But you have adapted that Little's law for doing the workload modeling like this. So in the interview, if they ask you Little's law, this is what your answer should be. But you can say that, you know, in our workload modeling, you have to have something called pacing, so you can add pacing to it. That's it. Okay, ZT plus RT is however the script execution time, plus you have to add the pacing to it. So I adapted the Little's law for workload modeling by adding the pacing. Okay, so in the interview, you give this answer, but again, you can continue and you say that for calculations of the pacing, you have to add the pacing as well. So this is the formula you use, and then you can come out with this particular formula. Okay, are we clear, guys? Are we clear? All of you? But why we have added the pacing, how the formula has changed, what is the logic behind that, please don't ask me, because I have to explain so much. Maybe it will take 2 days for me to, you know, give you that clarity. Okay? But trust me, as you do performance testing, as you do workload modeling, you know how this has been adapted and why this pacing has been added. Okay? Wonderful, guys. Now, we will start using this formula and we'll start doing the workload modeling. We'll start using this formula and we'll start doing the workload modeling. Okay? Now, before I started, we thought we will do the workload modeling for what? We'll do the workload modeling for what? This thing. This is how our whole chapter started. Now we will do the workload modeling for the same thing. Okay? We'll do the workload modeling for the same thing. So watch carefully. Now I'm doing the workload modeling. Okay, so I've copied the same data into my Excel sheet. Okay, now wonderful, guys. So I've copied the data into an Excel sheet. This is the NFRs we have received. Okay, type of the transaction is not important at this point of time. I'm hiding this column. Okay, okay. Now watch carefully. Watch carefully. What is the formula, guys? What is the formula? N is equal to throughput multiplied by script execution time plus pacing. This is the Little's law. What is script execution time? What is the script execution time? The total script execution time. Okay. Think time ZT. Okay. Sorry. RT, the response time plus think time. Response time plus think time. Okay. That is what is the script execution time. Now, what is the first thing that we have to calculate? The throughput. What is the first thing that we have to calculate? Throughput. Throughput is what? Transactions per second. Transactions per second. What do we have? What do we have? Transactions per hour. Okay. Okay. What do we have? Transactions per hour. So what is the first agenda we have to do? Convert that into transactions per second. Okay. Transactions per second. Okay. Convert that to transactions per second. Okay. Transactions per second. Okay, somebody who is little not so comfortable in maths, okay, you can take this template and start using this template, because I'm putting the formulas inside it. I'll send this template to you right away. You can use the template. Okay, now tell me, 1 hour is equal to how many minutes? 1 hour is equal to how many minutes? 1 hour is equal to how many minutes? 60 minutes. Okay, now 1 minute is equal to how many seconds? How many seconds? 60 seconds. Wonderful. Okay, now you tell me 1 hour is equal to how many seconds? 1 hour is equal to how many seconds? 60 multiplied by 60, 3600. If somebody doesn't know this, yeah, you have to remember this. Okay, it is a simple logic. 60 multiplied by 60 will give you the number of seconds. Okay, 1 hour 2 seconds, right? 60 multiplied by 60, 3600. So you see, transactions per hour, you have to convert to transactions per second. So what do? Divide this by 3600. Why you are dividing by 3600? Why you are dividing by 3600? Because 1 hour is 3600 seconds. 1 hour is 3600 seconds. Why? Because In 1 hour, you have 3600 seconds. So that's you're converting the hour to second, and this is a division. You see a division. Okay, 1 hour is what? 3600 seconds. So that's why you are dividing 700 divided by 3600. So we got the throughput. Same thing for this one as well. Okay, 1000 divided by 3600. Okay, same thing is here. 30 divided by 3600. Okay, same thing here. Okay, 10 divided by 3600. Okay, so I haven't done much here, guys. Okay, I have just divided the number by 3600. Okay, I've used the power of the Excel sheet to do that. I've used the power of the Excel sheet to do that. Okay, so if you're not comfortable using the power of the Excel sheet, you can go to the calculator as well. Okay, you can use the calculator, and you see what is the first one? 700 divided by 3600. Okay, whatever the number that you're seeing, you can plug it over here. Okay, so in Excel, if you wanted to use any formula, you can just say that. Okay, you can put an is equal to. For example, I wanted to add two numbers. Okay, 10 plus 20. You just say is equal to 10 plus 20 and you say enter. It will give you the answer. Okay, so any formula. I wanted to multiply 10 multiplied by 30. What do you do? Is equal to 10 multiplied by 30. It will give you 300. Okay, so Excel sheet will do the work for you, what a calculator would do. All you have to do is, in a cell you have to put is equal to. In a cell you have to put is equal to. Okay, so I hope that is okay. But somebody who's totally not comfortable with the Excel sheets and totally little lost as to what we are doing, stay back after the class. I'll teach you little tips of Excel sheet. Okay, which will help you. But don't hesitate to ask me. Okay, I'll teach you. Now we have calculated the throughput. We have calculated the throughput because we have to do the workload modeling for each one of them, right? We have to do the workload modeling for each one of them, right? So I've calculated the throughput for each one of them. Now you see, I do have the number of concurrent users, not yet. Next one is to calculate the number of concurrent users. Okay, so I got X from the formula. What do I got? I got X. Now I need N. Okay, so Phil, your answer will be, your question at the starting of the class will be answered at this point of time. Now, as a part of NFRs, let's say the client said that you need to run this with 600 concurrent users. Okay, overall they will tell you. Okay, this information the client will give you. Okay, you are supposed to run the test with 600 concurrent users. Where will you get this information from? Where will you get this information from? As a part of NFR. Okay, as a part of NFR, you will get that. Okay, sorry guys, as a part of NFR you will get. Okay, as a part of NFR you will get that. Okay, total overall the test I need to run with 600 concurrent users. Now we have this number called 600 concurrent users. Okay, watch carefully what I am doing. This is little hard to understand, but I'll do my best. You have to be little what do you say, little good with math to understand this, but I'll do my best to explain this to you. Okay, if somebody is finding it hard, they might have to listen to this video. This video is getting recorded. Hopefully it is getting recorded. Yeah, it is getting recorded. So listen to this video multiple times until it gets into your mind. Okay, but somebody who is little good with math, they will be able to understand. Not complicated maths, just the high school math. Okay, now there are 600 users, total 600 users. Okay, these 600 users will run only one business process, or they are supposed to run all the business process? Can somebody tell me? These 600 concurrent users are supposed to run only login, or 600 for the whole test, which means that for all of them? It is for all of them. How many of them we have? 1, 2, 3, 4, 5. So there are all 600 users, and there are 5 business process. Do you think it needs to be equally divided? Do you think it's fair enough to equally divide these 600 users across all the 5 of them? Right? Don't you think so? No? So, lot of people saying no. Okay, glad you're saying no. Depends, Rajesh saying. So the people who are saying no, can somebody unmute your mic and say like why it is unfair to divide this 600 across these 5 equally? I'm just asking you your opinion. It may be right, it may be wrong, but I want your opinion.
And because there's different load transactions for each business process.
Wonderful, wonderful. That's what I wanted to hear. Because for one business process there is 1,000 and the other has only 10. It is totally unfair to run this like this. Okay. In case if I have divided 600 equally across all of them. Okay. Equally across all of them. Okay. So each one will get 120. Okay. Each one will get 120. Each one will get 120. Okay. Each one will get 120, and let's look at the load this 120 is handling. This 120 is handling how many? 1,000 users, and this 120 is handling how many? 10. This is totally unfair, guys. This is totally unfair. Okay, if there are 10 people working under a manager, all the 10 of them should have the same work. It is totally unfair that one person gets all the burden, the other people will not get so much work. Okay. Do you agree with me, guys? Do you agree with me? If you're equally dividing this 600 across all the 5, what is this 120 users are doing? They are supposed to do 1,000 transactions. That's a lot of work as we compare to this 120 wherein they are hardly doing 10 transactions. Okay. So as Io said, it has to be proportional. Thank you, Io. You put the words into my mouth. Okay. Thank you. So it has to be proportional. More is the load, more should be number of concurrent users. Less is the load, less should be number of concurrent users. But when you add all of them, it should be how much? When you add all of them, it should be how much? It should be, when you add all of them, it should be 600. It should be 600. Okay? Right? Yeah, that's how it should be. Yeah, totally agree. Yeah. So, because the overall test you need to run with 600. So, when you add all of them, it should come to 600. Okay. So, now equally dividing is not an option. We have already discussed that. Some people in their workload modeling, they will do it. Okay. But I won't encourage equally dividing because you yourself are saying that that's not appropriate. Okay. So, some people I've seen they equally divide it across all the groups and they start doing the workload modeling, which I think is unfair and it should not be done. Okay. As Io said, we have to proportionately divide these 600 users across these groups. Okay. So proportionately means there are more load, more users should come, less load, less users should come. Okay. This is what I mean when you said proportionately divide them. Okay. So watch carefully what I'm doing. Okay. To be proportionate, what you do first is you add all of them. Again, I'm using a very, very small formula in Excel. What is that? Sum of what? Sum of all of them. Okay. So you're not comfortable using these formulas and all that. What you can do, you can open the calculator. And you can add all of them. You see, 700 plus 1,000 plus 800 plus 30 plus 10. How much it is total? 2540. You see, 2540. Okay. Somebody who doesn't want to use the power of Excel sheet, I'm totally okay. Go to the calculator and do it. But what did I do? Is that very difficult? Any formula, it starts with the is equal to. What I wanted to do, I wanted to sum. I wanted to do the sum. Sum of what? Sum of all these guys. Select all these guys and close the braces. And as simple as that. That's a formula. Okay. Sum of what? Sum of what? All this. What's going on? Okay. What's going on? Is equal to sum of all of that. Okay. Like that. Or if you're comfortable not selecting the cells, you can say sum of, okay, 700 plus 1,000 plus 800 plus 30 plus 10. Okay, close it, and even that wise you will get the same value. Okay. Don't think that I'm going what do you say, he's explaining very, very silly topics as well, very simple topics as well, because please understand that in our class there are some guys who are completely new to IT. They're starting their career in IT. They wouldn't have used the Excel. So somebody who's comfortable, you have to be little patient, guys. You have to be comfortable with the Excel and all that. They have used it before. You have to be little patient. Okay. Now you have added all of them. It is 2540. Okay. Now let's see the factor for this one. Okay. You see the factor for this one. You see the factor for this one. Okay. First we have to multiply proportionately, right? We have to multiply proportionately, right? Now you see how we can get to this number proportionately. Okay. So see this formula. 700 divided by 2540. Okay. Multiplied by 600. You will get the proportionate number. Okay. Again, I'm telling you how we can get the proportionate number. The transactions for that particular cell divided by overall transactions multiplied by 600. 600, why we are multiplying by 600? 600 is the number of concurrent users. 236. Again, watch carefully the formula. You are getting you want to divide it proportionately. So what do? The load of that particular group divided by overall load multiplied by number of concurrent users you wanted to go with. Okay, so that is what it is. Okay, again I'm doing it. The load of that particular load divided by overall load will give you the fraction or the proportionate of load, and then multiplied by the total number of concurrent users. So with 7 users. Okay, again the same story for this. The load of this divided by overall load will give you the proportionate amount multiplied by the total number of concurrent users. Why we are doing it? Because as you said, equally dividing, okay, equally dividing is not fair. It's not fair. Equally dividing is not fair. So we wanted to do it proportionately. How can we get proportionately? Add all of them. Now what is the first thing you will do? What is that fraction? What is this load of the overall load? What is the fraction of this load of the overall load? How do you get it? 700 divided by 2540. You get the fraction, and that fraction divided by the overall concurrent users, which is 600. So you got this 165. Similarly, you get the fraction of this load across all the other loads. How do you get the fraction? 1000 divided by 2540. You get the fraction of this particular guy, and multiplied by overall 600 users. Okay. If you didn't understood, blindly go with this formula. This divided by overall load multiplied by total number of concurrent users. Okay. How did I get the n? Okay. The user load divided by overall total load. Okay. Multiplied by total number of concurrent users. Total number of concurrent users. Okay. Again, this formula you have to remember, guys. This formula you have to remember. Somebody who didn't understood the logic, take that as a formula. Okay. Take that as a formula and you remember. How do you do it? The user load divided by the total load, which is 2540. Okay. Multiplied by total number of concurrent users, which is 600. You get the number of concurrent users that is required. So this is how you got the n. This is how you got the n. This is how you got the n. Okay. This is how you got the n. If somebody is wondering how you got the n, this is how you got the n. How, guys? User load. Okay. So in my first case, what is the user load? 700. Okay. Divided by what? Divided by what? Overall load, total load. What is that? 2540. 2540. Okay. So now, okay. So if you put is equal to, it will give you the number 2.2570. Multiplied by what? Multiplied by what? Total number of concurrent users. So multiply this by total number of concurrent users. Okay. Multiplied by total number of concurrent users. Okay. You will get this number 165. 165. Okay. Is it okay so far, guys? Is it okay so far? Is it okay so far? I'm not going to save this right now. Is it okay so far? Everybody following me? Everybody following me? I'm going really slow explaining the power of Excel sheet as well. Okay. So if somebody is falling behind, they would have to look at this multiple times and do little bit of research on how to put the formulas on Excel sheet and all that. Okay. So how to bring or how to create formulas on Excel sheet or how to calculate on Excel sheet, practice for a couple of hours. You will become comfortable with the Excel sheet and then you can come back to it. But you take this as a formula. If you haven't understood the logic of n, take this as a formula. All we are trying to do is divide the overall 600 across each group, the two proportionately, not equally. For proportionately, what is the formula we have to use? There is a logic behind it which I tried to explain, but if you haven't understood the logic, it's totally okay. Take this as a formula. Take this as a formula. Okay, take this as a formula. Okay, take this as a formula. Wonderful, guys. Wonderful, wonderful. So we have got the n. We got the n. So we got n in this formula. We got x in this formula. Both of them we have accomplished. Now the problem with n is, can you have, these are users, these are concurrent users. Can you have 165.3 users? Can you have 165.3 users? Is it possible to have half user or 1/4 user or 0.3 users? No. These are virtual users, which is given by the LoadRunner. It is either 1 or 0. It cannot be 0.5. Okay. That is the reason why you have to round it off to the nearest number. Okay. You round it off to the nearest number. Okay. If it is less than 0.5, you round it off to 165. If it is greater than 0.5, you round it off to the next number, which is 166. Again, I am telling you, you see 163.5, right? Sorry, 163.3. 0.3 is less than 0.5, so you round it off to 165. Okay, you see 263.2, which is less than 0.5, so you round it off to 236. But you see 188.9, so which is greater than 0.5, so you round it off to the next number, which is 189. Okay, like this, you can round it off to the nearest number. Okay, if it is less than 0.5, it's the same number. If it is greater than 0.5, the next number. Now you make sure you add all of them. You add all of them, and it should be, the sum should be equal to 600. But what is the sum? It is showing at the bottom. You select all of them. What is the sum? It is count is 5 and sum is what? 599. So increase one number somewhere. Wherever you think is appropriate, increase that number. Okay, so that the overall sum is 600. Now you add all of them. It is 600. It is 600. I'm pointing the mouse at that sum, guys. Okay, if you want, you can calculate this as well. How do you calculate? It's equal to sum of 165 plus 237 plus 189 plus 7 plus 2. Okay, which is 600. So you wanted to run a test with 600. You have accomplished 600. Now your n is 600. Wonderful, guys. So in the formula, you have dealt with n and x. Okay, you have to do calculations. Now, Phil, are we clear how we have broken this across all the business process? This was your first question at the starting of the class. So your first question is answered, Phil. Phil, are we okay? Wonderful. So your first question is answered now. Okay. Are we done yet? No. What is the whole purpose of workload modeling? Pacing. What is the whole purpose of workload modeling? Pacing. Now script execution time. Okay. Script execution time is something that you calculate, or you create the script and you run the script and you get it from there. Okay. Again, I'm telling you, script execution time is something that you calculate, or you create the script, you execute the script, and you look at it and you put it over there. Can somebody tell me? Okay. Straight up, we assumed it's 10 minutes for login, but we don't know, right? How do you get the script execution time? You create the scripts, okay? You execute the scripts, okay, with the think time and the response times, and we will look at it with our naked eyes, and yeah, we run it for once and we look at it with our naked eyes and see what is that number. So this is not something that you calculate. This is something that you create the scripts and look at it. Okay. For example, the script execution time for login, let's assume, yeah. Yes, Shraddha, that's exactly what I'm saying. Okay. So now you see script execution time for login, let's say it is 3 minutes. How many minutes? 3 minutes. Now in our calculations, is everything is in seconds or minutes or hours? In this whole formulas that we are putting, everything that we are calculating, we are doing it in seconds. So let's convert to seconds as well. The script execution time will convert to seconds as well. Okay. Okay, is converted to seconds as well. So let's assume it is 3 minutes, which is 180 seconds. Okay, it's just an assumption, but in the real world, you have to create the scripts and you have to execute the scripts and we have to look at it and we have to put the number over here. We have to put the number over here. Okay. Okay. So similarly, let's say for account summary details, let's say it is 5 minutes. 5 minutes means 300 seconds. Okay. And let's say this is also 300 seconds. Let's say this is 240 seconds. Let's say this is 180 seconds. Again, but in the real world, what you would do, you create the scripts, you execute the scripts with the think time. With the think time, you execute the scripts and calculate the script execution time. Okay, I'm putting some random numbers, making some assumptions, but in the real world, you would have to execute the scripts and get the numbers and put the numbers over here. Okay, now you have the script execution time. So we have all the things. Now we can calculate the pacing. You see, n is equal to x multiplied by script execution time by pacing. In this formula, you have n, you have x, you have script execution time. All you have to calculate is pacing. All you have to calculate is pacing. Now see what is the formula looking like. Okay, this is the formula, right? This is the formula, right? Now you have to calculate the pacing. Okay, script execution time plus pacing is equal to what? Is equal to what? N divided by here is the multiplication. It went to the left hand side. This is the right hand side and this is the left hand side. Okay, whatever is there on the right hand side went to the left hand side, and you have a multiplication here. So what it will become? Division. What it will become? Division. Okay, n divided by x. Okay, so what is pacing now? What is pacing now? Okay, n divided by x. N divided by x. What is the pacing now? What is the pacing now? N divided by x. N divided by x. Divided by x. Here is the addition. If it goes to the other side, what will happen? Here it is the addition. If I go to the right hand side, what will happen? What will happen? Subtraction. Okay, now that's the formula. Pacing is equal to n divided by x minus script execution time. Okay, so first for calculation of pacing, what I will do? I'll calculate n divided by x. Okay, I'll calculate what? N divided by x. I'll calculate what? N divided by x. You see, first I'll calculate what is the pacing, guys. I'll put the formula here. Pacing is equal to n divided by x multiplied by script execution. Sorry, subtracting script execution time. First, I'll calculate n divided by s. N divided by x is equal to, you put is equal to, what is n? Select that cell. Divided by what is x? Select that cell. Enter. So that is n divided by x. Now again, do the same thing. Okay. What is n? 237. Divided by what is x? What is that number? Okay. So similarly, do that for all. You just hold it and drag it. Automatically, the formula applies for next cells as well. Okay, or else you can manually type it. If you are not comfortable with this, what would I suggest? Is equal to, what is n? 165 divided by what is x? 0.194444. Okay, you get the same number as well. Okay, you can do that. Now you got n divided by x. What is pacing? N divided by x minus script execution time. Finally, you have the pacing. Finally, you have the pacing. So n divided by x minus pacing minus script execution time. This one. Okay. So this is what is pacing for each one of them. So you hold the formula and drag it across to all the lines. It will happen. But if you are not comfortable doing that, is equal to n divided by x is 853.2 minus script execution time is 300. You can do that as well. Okay, so this is how the pacing needs to be calculated. I know you need to have little of mathematics knowledge for this. Okay, but if you listen to this video a couple of times, you will get a hold of it, whoever has not understood. But I tried my level best, guys, from my side. I know some of you might be falling behind. Okay, but you would have to listen to this video again and again. You would have to listen to this video again and again to get a complete hold of it. So this is how you can calculate. Okay, so this is how you have to calculate. This is how you have to calculate the pacing. This is how you calculate the Okay. Okay. So now we have done the workload modeling, guys. We have done the unknown is always is the pacing. The unknown is always the pacing. If you get the pacing right, you get the load right. If you get the pacing wrong, okay, if you get the pacing wrong, you get the load wrong. Okay, why this pacing is important, I'm telling you guys. If you get the pacing wrong, you get this load wrong. Because the number of concurrent users doesn't change. You have to run it with 165. But if you got the pacing wrong, then the load that you achieve could be wrong. Okay. Yes, Satish. Sorry, Satish, it is only today it is extending more than the regular class timings, but typically we wrap it around 8:30. I'll share the video with you.
No problem, no problem. So,
Yeah. So
thank you.
it's just that I've started the concept. If I start tomorrow again, I have to explain the whole thing from the first. I hope, Satish, you're okay with that.
Oh, yes, sir, yes, sir. No
Yeah.
problem.
Yeah, please.
Thank you.
Thank you, Satish. So this is what is the workload modeling, guys. This is what is the workload modeling. Okay. Now, there is one last thing that you need to know before I wrap it up. Is it okay, all of you? Is it okay, all of you? Is it okay, all of you? Yes? Okay. Wonderful. Thank you. That gives me some confidence. At least 50% of the class understood, I believe. Okay. With all the efforts that I've put. Okay. Now, the problem here is if you go with this pacing, there are some, what do I say? There are some shortcomings. There are some issues. Okay. I'm not going to talk about these issues because if I start talking about these issues, some of them might not understand. Okay. Okay. First, let me take the question. So, Shraddha, please go ahead, ask the question.
Sir, I am asking, you have calculated a SET column for one transaction only, but we have 700 transactions.
We are doing it only for one, right? The script execution time is only for one. That's how it works.
Okay.
Okay. You are supposed to do it. The formula is so designed, Shraddha, is that the script execution time needs to be calculated only for one iteration. Okay. So if you have any doubts, Shraddha, that is the reason why I came from this. Okay. So you see, the script execution for this time is 10 minutes. So based on this 10 minutes, we got this pacing as 10 minutes. Okay. So that's how it is. That's how the formula is. Okay. The formula needs to be taken care of only one iteration. The script execution time only for one iteration, not for all the 700 of them. If you are taking the script execution time for all the 700 of them, then automatically this becomes 1 in the formula. Okay, so we are not supposed to do that. The formula, we have put this as 700, then for each one of them, what is the script execution time, we have to put it. Okay, now there is a shortcoming. The problem is the script execution time that you have calculated, it will not be 180 all the times. As Shraddha said, it needs to run 700 times in that 1 hour. One time it could be 178, one time it could be 182, one time it could be 188. It cannot be 180. Yeah, you have created the scripts, you have executed the scripts for one iteration and you got the number, you plugged in over there. So there will be some issues with the script execution time. It will not be same all the time. As the server load is changing in the real world, as the server load is changing, the script execution time also changes. Okay, why it happens that way? Okay, because it is dealing, the script execution time is dealing with the response times, and if the server load is less, the response times will be less. If the server load is more, the response times may be more. So the script execution time is changing with the load. So this is not a standard number, even though in the class we have considered this as standard number, but it cannot be. Okay, if you haven't understood that point, it is still fine. So the point which I'm making is the pacing that we have calculated, which is n divided by x minus script execution time, is not 100% correct because the script execution time changes all the time. So this is a shortcoming. Okay. So yeah, it's not a good starting point. So there is a workaround for that. I'll tell you what it is. Okay. Now carefully look at it. I am going to the ViewGen. Okay. Let's say I've created a script called login script. I've created a script called login script. Okay. Now, wonderful. This login script is created. You have captured the launch transaction, think time, login transaction, think time, and log off. Everything you have captured in this script. Now the script is ready. Now let's assume the script is ready. Where will you put this pacing? You have calculated the pacing, right? You have calculated the pacing of 668. So where would you put this pacing? Okay, watch carefully. There is something called runtime settings. There is something called runtime settings. The settings RTS which you apply. Okay, RTS, runtime settings or RTS, which is applied while running, which is applied while running. So just open the RTS, just open the RTS and you go to a column called pacing, and this is where you apply. Okay, this is where you apply. What is the pacing that you got for login? What is the pacing that you got for login? 668.5. 668.5. 668.5. This is where you apply. This is where you apply the pacing. This is where you apply the pacing. Okay. Are we okay so far, guys? Are we okay? I know I haven't demonstrated the VUgen for you. Okay. But all I have done is open the VUgen, created a simple script called login script, and so that I can demonstrate it for you where we can put this pacing. Only I wanted to show you where we can insert the pacing. Okay. Okay. I have created a script called login script. Okay. I've created a script called login script. This is the login script. Okay. This login script, we have calculated the pacing is what? 668. So we have to put that pacing somewhere. Just double click on that and then click on that pacing and you select the option. This is no pacing. This is no pacing. This is no pacing. Okay. This is pacing, which is 688. How did I get this number? From the Excel sheet that we have done, 668. But is that what people do in the real world? No. Is this what people do in the real world? No. This means no pacing. This means the actual pacing that you calculate. But what would the real people in the real world will do? Go with this one, the third option. What is the third option? N divided by X. What is that? 848.5. 848.5. So even though for the calculations you might calculate this, but in the scripts you use N divided by X. What is N divided by X, guys? What is N divided by X? What is N divided by X? This is pacing plus script execution time. Pacing plus script execution time is N divided by X, and this option is what? Pacing plus script execution time. This third option is what? Pacing plus script execution time. This option is what? This option is what? Just pacing. This option is what? Just pacing. Okay. So the third option is pacing plus script execution time. Okay. Which is this number. And the second option is what? Only pacing, which is N divided by X minus script execution time, which is this 688. So if you are going with this option, you have to plug this number 668. And if you are going with this option, you have to use 848. Okay. What is the people use in the real world? Everybody goes with this number, which is the third option. Because you are taking away the script execution time from your calculations, because script execution time will change from iteration to iteration all the time depending on the load. So this is the reason why all the people will use every single performance tester who is little bit of knowledge or experience, they go with the third option. And if you're going with the third option, it is much more easy. You never have to calculate the script execution time. You never have to calculate the script execution time, which means that you never have to calculate the actual pacing. All you calculate is N divided by X. So your formulas and everything becomes much more simpler. Much more simpler. That is the first point. Why we are using the third option? Why we are using the third option? Okay. Why we are using the third option? Okay. Why we are using the third option? The third option is what? The third option is what? This one. Okay. I'll tell you first. The first reason is script execution time always changes from iteration to iteration. So there is no way you can calculate the accurate script execution time. Okay. So we cannot. So we can never calculate accurate script execution time. Okay. That is the first reason. Second reason is workload modeling is happening in which phase of PTLC? Workload modeling is happening in which phase of PTLC? I know it's a long day, guys, but I need
design phase.
Test design phase. Test design phase. Okay. Workload modeling is happening in the test design phase. And when will you have scripts? In which phase the scripts will come? In which phase we will create the scripts? And test design phase is the second phase. Okay. And the scripts are creating in the third phase of PTLC, which is test design and development. test, design and development. So by the time you're creating the workload modeling, do we have the scripts? By the time we are creating the workload modeling, do we have scripts? No. If you don't have scripts, how can you have a script execution time? So we will not have the script execution time. Okay, workload modeling usually happens in the test design phase, which is the second phase. The scripts will be created in the third phase of PTLC. So when you're doing the workload modeling, you don't have the scripts. If you don't have the scripts, you cannot have the script execution time. You cannot have the script execution time. So there is no way you can get the script execution time. So because of these two reasons, all the performance testers will go with the third option. All the performance testers go with the third option. If that is so, Kumar, why did they give the second option? I mean, some people might not follow the performance testing life cycle, we never know. Or they are in the agile and they don't care about, all this. So they have calculated the pacing and they put the number over there. So don't know. At least I haven't seen anybody using the second option. Okay. So we have a performance testing center of excellence in the company, in the last company that I've worked, close to 500 performance testers. Okay. So I've spoken to most of them. Nobody uses the second option. I was trying to figure out why there is a second option as well. So maybe in some things like agile and all that, probably they might use it. Okay. Anyways, so in your projects going forward, you are supposed to use this. Okay. You are supposed to use this. And if you're using the third option, you need not have to calculate the script execution times and you need not have to calculate the actual pacing. What you calculate is n divided by x. N divided by x. So if you are not calculating, Kumar, why did you even waste our time in this one? You never know, in the interviews or in the project that you go, maybe they might be asking. Okay, maybe they might be asking. So I thought, I should cover that because you are my student and I wanted you to know everything possible. Okay, so yes. If you calculate n divided by x, which should be good enough, and you calculate n divided by x, put that number in the third option, not the second option. If you haven't understood any of these reasons, it is still fine, guys. What you do in the projects is calculate n divided by x, and you plug that number in the third option. Okay. So now let's say you have created this account summary details script. Let me create that account summary details script. Okay. Account summary details. Okay, so detail script. I've created this account summary detail script. For what is the pacing for the account summary detail script? The actual pacing is 553, but n divided by x is 853. The actual one is 553. Okay, the n divided by x is 853. Now I'll open the runtime settings of this account summary. I'll open the runtime settings of account summary. This runtime setting is for the login script. This runtime setting is for account summary details. Open the runtime settings for this one. Okay, go to the pacing. Now, if I am choosing 853, where will I enter? In the second option or the third option? I want to hear from all of you guys. If I am choosing to enter 853, where will you enter? In the third option or in the second option? I wanted to hear from all of you. Third option, 853. Okay, so that's the one. This is what I wanted you to know. As long as you understand this, we are in a good shape. As long as you are understanding this, we are in a good shape. Okay, like this, you can start creating other scripts as well. You can create the checking transaction history. You create one more script called checking transaction history, and you can plug in this number pacing 850 for that particular script. Okay, now our workload modeling is done, guys. Workload modeling is done. This is an extremely important concept. A lot of people shy away from doing the workload modeling. Somehow they find it difficult. After 2 years, 3 years of performance testing, 5 years of performance testing, somebody says workload modeling, they will be scratching their head. Actually, you understand the concepts. It is very simple. I try to start from the basics so that you can visually understand logic. I started with 6 transactions, then I started with 3 login transactions, then 12 login transactions. So in the 3 login transaction, I explained the concept of pacing. In the 12 login transactions, I've explained the concept of concurrency. Then I came out with the NFR with 6 login transactions with 2 concurrent users, so that what would happen in the reality. Then I went into the Little's law and slowly explained you why we need to have a law as well. And finally implemented the law for all the business process, for all the each and every business process. So you have 50 business process. You would have to do the workload modeling for all the 50 of them. If you pay attention, it is a 1 hour task, guys. If you know Excel sheet well, it is hardly 1 hour. Okay. Now today I'll give you an assignment. I'll save this and I will send this across to you. Okay. Workload modeling. This is for Mercury Web Tools. Okay. Let's say Web Tools. So I'll give you an assignment. Okay. I'll send it across an assignment. First, let me walk through the assignment. I know there are some questions which are pending, guys. I'll take it. Already I've extended it. So first let me explain this assignment, and then I'll let whoever wants to leave, they will leave, and then I'll take the questions very peacefully of Phil, and if I have missed somebody, I'll take that as well. Okay. So your application under test is Amazon shopping website. Okay. It's an e-commerce application. The peak hour is 9 a.m. to 10 a.m. Okay. So these are the numbers that you have collected for the peak hour. These are the numbers that you have collected for the peak hour transactions. These are the 4 different transactions. You don't have 50. You have only 4 performance critical business process. For each one of them, we have collected the transactions per hour using Splunk or using any of the tools, or let's say they have given this. So this is the NFRs they have given. This is the NFRs they have given. Transactions per hour. This is the NFRs they have given. Okay. So I'll take away all the numbers here. Okay. Let's assume this is the script execution times for each one of them. And the overall concurrent users is 700. The overall concurrent users is 700. Okay. Overall concurrent users is 700. Okay. Now, please calculate or please do the workload modeling for this. Okay. So this is the assignment which I will be sending you. Okay. Is the assignment clear to all of you guys? Is the assignment clear to you? It's an Amazon online shopping website. Okay. It's an e-commerce application. The peak time is 9 a.m. to 10 a.m. during which we have collected these transactions per hour. It could be using Splunk, or it could be because they have given that data to you. Okay. And they also told you that in that peak hour, how many concurrent users are there? 700 concurrent users are there. I have already created the template. Okay. And also I'll give you the formula. What is the formula, guys? Somebody please unmute and tell what is the formula. N is equal to X multiplied by script execution time plus. Wonderful. Thank you. Please. Thank you. Okay. This is the formula that you will use. Okay. In the real world, N divided by TPS is used, but for our calculations, we'll calculate the pacings as well. So the whole template is there. You can use this template right away into your projects, guys. Yes. Not only here, in general, the script execution time includes the think time field. In general, the script execution time includes the think time. Okay. They're not realistic, but let's assume that's realistic. Okay. The script execution times is way too less. Okay. It doesn't look realistic. Or maybe what I'll do is I'll increase this to 1500. Then I can add more pacing, the script execution times here. Okay. Or maybe I'll say 2000 here. Okay. Then I can have some realistic pacings. So script execution times. Okay. So let's say. Okay. This is what it is. Okay. So I expect everybody to attempt this assignment, which is very, very important. Okay. As a resource, you are doing workload modeling, you will be considered special in the company, guys. You will be considered special or unique. So in the interviews as well, if they talk about workload modeling, I'm telling you, so you practice this multiple times. And if they're talking about workload modeling, spend at least 5 to 10 minutes. Okay, they should totally understand that you are very, very confident about workload modeling. Okay, so I want you to talk about this in the interview in case if they didn't ask you as well. For example, they will ask you, okay, what is that you are involved in? Okay, this is the first question they will ask you. You say that I'm involved in collecting the NFRs because you know now what NFRs are. I've given you the samples as well. And you say I've created the test plan as a part of it. I've done the workload modeling. So you spend a little bit of time over there. As a part of workload modeling, we know we have to calculate the pacing. I've used the Little's law for that. And I got as a part of NFR, I got this. So you talk about that. Okay, in case if they're not, like to talk about it, because you've learned this, and not all the people know it. Because I know at least there are 6 performance testers in the class. Okay, so if you know it, it's fine. But if you don't know, I'm sure some of them might not know this workload model. Okay, and they might be doing performance testing maybe from the last few months. Okay, so this is not something everybody knows, guys. So spend some time, learn it, and then do this assignment, and then you automatically will learn it, and then you can talk about it confidently in your interviews. So on that note, I'm wrapping up today's class. So I know I have some questions pending. I'll take those questions. Whoever wants to stay, they can stay back. They can continue to ask the questions or listen to the answers that some other people have some questions. Okay. Okay. So now, oh, Phil, you have to go. Okay. I thought I will answer all your questions. Okay. So if you just give me 5 minutes, I'll kind of, give you the answers, because it's kind of hard for me to type all those answers. Okay. Just give me 5 minutes. Because only you are the ones who have the questions. Because nobody else. All I need is 5 minutes. Okay. So the first question, Phil, is, does every flow needs to, you have to put the transaction? Yes. You're capturing the launch, you have to define the transaction, you have to have a checkpoint, then think point. Capturing the login, you have to capture the response times for login. Whether they have asked for it or not, you have to wrap that around the transactions and you have to capture it. You have a log off, whether they wanted it or not, they asked for it or not, you have to capture it. Because when can you say application is fast? When every single transaction or every single request that is sent to the server and response that you get is fast, then only then you can call an application is fast. So as a performance tester, whether your client has asked for something or not, but still you have to capture every single transaction that is there in that particular business flow. You have created the login business flow. They have asked for only login transaction. It is still fine. You have to capture the response time for launch as well as the log off, even though they never asked for it. So Phil, I think I've answered that question. Phil, have I answered that question? Yeah. Are there any other questions pending? One is the open systems and closed systems. Other than that, are there any other questions pending? I hope no. So closed systems and open systems, I think I need some time and you don't have the time. So tomorrow after the class, we'll take it, or you can search it. So the transaction time plus the think time is the total script execution time. Yes, we have to consider in that business flow, let's say there are 5 think times and 6 transactions. We have to add all of them and then come out with the script execution time, which you can use it in the formula. That's what formula means. The formula means in that business flow, how many of them are there? Let's say there are 6 transactions and 5 think times. You have to add up all of them and you have to give that number over there. And that's how the formula is built. That's how the formula is built. Okay, that's the second question. Okay, any other questions? And if you stay back, I can explain the closed systems and open systems as well. It will take 5 minutes. Or we will continue tomorrow. As you wish.
I got a question.
Yeah, please go ahead.
Okay. What about if you wrapped a transaction around the full script from beginning to end to get the total response time?
Yeah, you get the script execution time for that. And it has only value in your workload modeling. It doesn't have any significance or value in terms of performance testing. Okay, so that will have the significance only for calculating your script execution time or for workload modeling sake. And we have understood that nobody would do that. Okay, we will not calculate the actual pacing. We'll calculate n divided by x. So there is no point doing that, honestly speaking. And in terms of the performance of the application, it is having zero significance. It is just for the performance tester. Yes. If you're interested, you can put it. And simple, open systems means the output is just gone. It's not there. Closed systems is the output, the input is dependent on the output. As simple as that. All our web applications are closed systems. In a way that first the server has to serve the request, only then it can take the next request. Okay, that's what is the closed systems. Okay, the server processing depends, the input totally depends upon the server processing. That's what is the closed system is about. Open system is irrespective of what server is doing, it doesn't matter, you will be sending the information. That is the open system. Very rarely happens. For example, Phil, when can you have a login request? Only after the launch is done. When can you have a launch? Only when the server sends back the launch request, then you can send the login request. So the input is dependent on the server processing time. Do you agree with this, Phil? Do you agree with this? Yeah. When can a login let's say this is the business flow. Launch LAUNCH, launch transaction. Okay. Then you have a login transaction and then you have a log off transaction. Okay. Now I have a simple question to ask. Okay. When can you have a login transaction? Only when you can get the response for launch transaction, then only you can initiate the login transaction. Which means that only after the server has processed the launch transaction, then you're ready for the login transaction. So the input load totally depend upon how fast the server is processing. Okay, it is dependent. So if the server is able to process this launch fast, then it can expect more load. If it's not able to process this launch transaction fast, then there will not be this login transaction. So this login transaction or incoming request totally depends upon the processing time of the server. So this is what is called the closed systems. This is off topic of others, guys. Phil is interested about open and closed, so I'm explaining. So it is closed. Okay. So the load or the next transaction depends upon the processing time of the processor. Okay. There are some systems wherein, irrespective of whether processor has processed is done, they will be sending the request. That is the open system, which rarely happens. Maybe in the satellites or something like that. Satellites is sending the data to you. Whether it doesn't matter if the server is able to process that data or not, satellite will be it will just keep sending the data. That's an open system. But these web applications and all that, they're all closed systems. Okay, so I've closed all the questions. Any other questions, guys? Shraddha, do you had any questions that are open? Shraddha, or I don't know, anybody else have any questions which are open? Today it went more than expected, I know, guys. I know. Sorry about that. Any questions which are pending? Anybody, guys? Anybody? Any questions which are pending? Yes, Phil. Yeah. Open systems, it's a little hard to control. Yeah, and you don't have the formulas for that. It's very hard. Okay, I have an announcement to make, guys, to all the people who haven't logged off. Tomorrow also at the starting of the class, I'll make this announcement. Very, very important announcements. Okay, so this is IST. Okay, weekend classes. I have been talking about these weekend classes from last 3 weeks. Okay, very, very important. I want everybody to understand, everybody to attend this class. Okay, even though some advanced topics, some topics that I haven't promised as a part of the coursework, I'm covering as a part of this weekend classes. What is this weekend classes, guys? Okay, some topics which students requested, okay, but not part of coursework. Okay, either these topics are covered, or what are the other topics? This is the first one. Either these topics are covered, or second one is some interview questions. frequently asked. Okay, frequently asked. So these questions are covered as a part of weekend classes. Okay, so somebody who is preparing for the interviews, they are definitely need to come. Okay, come to these classes or attend these classes. And somebody who have requested for these topics definitely need to do it. Some people have requested for what topics? Let me tell you. Web services protocol. Okay, protocol, Jmeter, and Dynatrace. Okay, this will be covered as a part of this weekend classes. Okay, which was never part of the course, which will help you with the interviews as well. Why? Because these topics will help you with the interviews. Second one is frequently asked questions. Some students are preparing for interviews. So for them, this applies. Okay, so the students who are preparing for the interviews, both of them apply, because web services protocol, Jmeter, Dynatrace, all that is required to break the interviews. Okay, and then frequently asked interview questions are also there. Okay, so this is the agenda for the weekend classes, which is never the part of the coursework. If I make this as a weekday classes, my course will go for 4 months. Okay, which I don't want it to do. Okay, so that's why weekend. Now, what is this weekend classes is about? Okay, weekend classes, it's not 1.5 hours. It will be more than that. I can't guarantee how much it will be, but please trust me that it will not extend beyond 3 hours. Okay, it will not extend beyond 3 hours. Okay, but it will definitely not be 1.5 hours. It could be any time, but it should be less than 3 hours. Okay, so I cannot guarantee how long it will be. Okay, so this is what it is. Now, weekend classes could be 1 day or 2 days. Okay, depending on it. This week I have only 1 day. Now, for Indian students, what is the time? Let's see what is the Indian students. What is the time? Sunday morning. It starts at 8 a.m. Expect the class to go till 10 a.m. or 11 a.m. depending upon how fast we are completing and how many questions you have. Okay, it starts at 8 a.m. sharp. Watch out for that group. I might be sending you the reminder. Okay, so definitely you will get the reminder, and use the same link. No changes in the link. You use the same link that you're using to join today. Okay, now we convert this to the US students. So I'm converting this to EST. So what is this time? So Sunday, let me look at it. Sunday 8 p.m. Let's see the time. Sunday 8 a.m. IST to EST. Okay, let's see what it will be. Okay, it is IST
9:30.
9:30. Is it Saturday night or Sunday night?
Saturday night.
It's Saturday night, right? So are we sure about that?
Yeah. EST.
Eastern Standard Time. Okay, so
Yeah.
yeah, so today, let's say 8 a.m. Okay, hang on. I want to be totally comfortable. Okay, so today 8 p.m. Today 8 p.m. is Wednesday. Today is Thursday. So you are 1 day behind. Okay, so which means that it is Saturday. Okay, Okay, evening for you, for all the students. Saturday evening for you. And what is the time, Rakesh? 9:30, right?
9:30. Yeah.
9:30 p.m. Okay, so this is EST. So convert it to your time zones, guys. This is your IST. Okay, IST means Indian Standard Time. Okay, so all the students in India, there is no, don't give any excuses. Okay, this is extremely important. Please come. Okay, please attend this class. This is only what I can say. I'm putting a lot of efforts. This is not part of coursework, but I'm still taking this because only for you. Okay, so this starts at 8. Expect it to go till 10 a.m. Okay, maybe 11, but might not be, because for people in EST, it's 9:12, so I don't want that to.
Specific time,
Okay.
right?
Okay, so now EST, okay, it starts at 9:30 p.m. Okay, for others, you can convert it to your time zones. Okay, you can convert to the time zones that you have. If you have any doubts, let me know. I'll convert it to your time zones and I will give it to you. US students, it's Saturday evening, guys. US students, it is Saturday evening. Okay, so this time Kumar, I'm not available. Will it be possible to record, send the weekend classes? Yes, everything will be recorded, guys. Kumar, everything will be recorded. Okay. So don't worry about it. I'll record and I'll send it to you. But don't depend on the recorded videos. Please come to the class and listen to the questions live, and please ask the correct questions. Okay. So this is what it is, guys. So wonderful. Meet you tomorrow at the same time. And then again, the next class will be on Sunday. Okay. Thank you. Any
Yep.
questions?
Thank you.
Any other questions?
Bye.
Yes, Kumar, I have a quick question.
Yeah.
Can you hear me?
Yeah. Yeah.
Okay. Okay. So, I was just wondering, this might be just a little bit off topic from what you just said, but like as far as I am learning from videos 7 and on, just on my own,
Okay.
and there are a lot of like LR functions and C functions. There's a lot of like coding syntax and stuff like that that needs, you know, like, is there a way that you would suggest that I should be studying those? Like, as far as like, I mean, I understand everything. Like, I totally get the concept. I totally get how everything is applied and everything. But then again, because it's so much, every time I try to go back and just think, okay, so how was that? And I can't seem to think of it from the top of my head. And is there a way that you would suggest that we should be
Yes.
studying something like this? Okay.
Yes. I'll tell you a trick, but some of them have some questions over here. Just 10 more minutes, I'll get to that point. Okay.
Okay. All right. Perfect.
Yeah, Kumar, I think I've answered that question, Kumar. So I'll be recording the sessions and giving it to you. By the way, in the class there is one more Kumar. Kumar means I'm not referring to myself. There is a student called Kumar. Okay, so
Okay.
next Samir. But initially it is planned for IST evening. Yes, Samir. But this weekend on Sunday, I have parties. I have to go out with my family, and I've discussed with my family, and they wanted at least my Sunday evenings. So unfortunately, I had to change the plans. I hope you understand that, Samir. Okay. And yeah, so that's what it is. Yeah, originally it was in the evenings, but I had to do that. So certain things I have to do for the family as well. So I hope you understand that. Okay. So next, coming to Melly. Okay. So Melly, watch this carefully. Any LR function, okay, you cannot remember all the functions that you have. Okay, LR underscore. Okay, Melly, are you looking at it?
Yes, I am.
Okay, so all the functions either starts with web or LR. This is the first thing that you need to know. Okay, do you agree with me?
Okay. Yes.
Okay, either starts with web or LR. The logic is LR means it is applicable to all the protocols. Okay, all protocols. You do know that. In LoadRunner there are all multiple protocols. These LR APIs or the functions are applicable to all the protocols. Web means it applicable to only web HTTP HTML protocol. Okay, so this is the first thing that you need to understand. Okay, so
Okay.
any function in our web HTTP HTML protocol starts with web or LR. Okay, now let's say you can't remember any of these functions. You just say LR underscore, it will start with that, and say control space. It will give you all the functions you have.
Yes.
You can get a ballpark idea as to what you wanted to use. Let's say LR rand over point. Let's say you are putting a rand over point. So you just double click on that. Okay, you have the function. Okay, you not have to remember the whole of it. That's the first thing. So as soon as now, the second thing, okay, watch carefully this, Millie, which is important. Okay, the second one is click anywhere on the function and press what? F1. F1 is for help. F1 is for what? Help. You will get the help on that. Now, you need not have to build it. Just go to the example. Copy that example, and you just put it in your script. And now you just change this to whatever you want. This is a random point. Let's say you're putting it for login transaction. Simple. Got it?
Yep.
This is
Definitely.
Everybody does this. It's not just you.
Yeah. Definitely. Yeah. I mean, I get that one, but then again, like for instance, for under C function, there's like a lot of syntax, like for if and else and stuff like that, right? So when you demonstrate it, I understand it, and when I practice it, I understand it and everything. But then again, I go back like 2 chapters, 3 chapters later, I'm thinking about it. Okay, so do I still remember it? You know, is what I'm trying to say. Like, how do I compile all of this? I remember it when I see it, and when you talk about it. But then again, I always ask myself, and do I still remember it? And I feel like I don't remember it. You know.
So the only way is to use a lot of practice. This is the reason why I'm giving you projects.
Yeah.
Okay, I am planning to give, depends. As a part of it, I wanted to give 1 project, but if you're passionate about it, I can give you 3 projects or even more. Okay?
Yes. I need a lot of
You can
projects
get
because that's the only way I can remember. It looks like, you know, like by looking at it more and more, and getting hands, because I'm not really doing it a lot right now. Maybe that's why I feel like I'm forgetting it. But
Exactly.
I guess when I practice it more is probably when. But I know this method that you just told me, just showed me. I've been practicing that one, the LR, how to the F1 functions and the control space and stuff like that.
Yeah. So you say if you can't remember how to use this if loop, just click on that, press F1, click on the example, and then copy paste it. Just say copy and paste it, and see how you wanted to use this for your script. How you wanted to use it for your script.
Really?
That's what it is, right?
So you can just change it there?
Yeah.
You can.
Yeah, change this here, put else loop whatever you want, and then if you don't need one more else loop, take it away. That's it.
Oh wow, that is a trick now. Like, I never knew that. That's awesome.
That's what I've been telling you, right? If you don't know, say while loop, just type while, okay?
Yeah.
Just type while, click on that, press F1, go to the example, okay? This is the while loop, copy it, okay?
Okay, that's
Then
amazing.
put it over here, and then start using it. Just customize it.
Amazing. Okay, perfect. Sounds really good.
Sounds good, right?
All right. That's a trick. Yeah, that's a good one.
But later on, you just have to try to type. Okay? So
yeah, I mean, I want to know it, so I don't want to. I don't prefer to go shortcut, but like, there are some times probably that I need it, so I'm gonna use it definitely for those. Yeah. But I like to
face this at the starting of my career, because I'm not a software engineer. Honestly, I'm an electrical engineer. Okay, I did my master's in electrical. Okay, electrical.
Right.
So me and coding are not together. Okay, honestly. Okay? I was scared just by looking at if loop. I used to be like overwhelmed. Oh my god!
Yeah.
There's a lot of programming, and for loop. It was like, oh my god, for loop.
Yeah.
So then I figured out this. Okay.
Yeah.
Then I used to then the first phase 1 of my career. Okay, copy paste, just like what I've done. Okay. Then phase 2 of my career. Okay, phase 2 of my career. Then I said, okay, let me try typing it. Okay. Then lot of mistakes. Okay, start typing it, compile it, issues. Then what I used to do, again go get the actual code from the example, put it, and observe where I have done the mistake. Okay, for example, if loop, the initial problem I always used to face is capital F I used to use, because in English language that's how we start, right, with the capital letter.
Yeah.
Okay.
Right.
So I used to do that. Now if I compile immediately, it used to throw the error, and then everything used to make sense to me. Everything happened correctly. Where did it go wrong? Then immediately I go, okay, press F1, okay, copy paste it, go to the example, copy paste it. This is what is the if loop, right? Copy paste it. Now compare, okay, compare apple to apple comparison now. You see, compare. Where did I go wrong? Where did I go wrong? So compare each one very carefully. Then I realized that, oh, it's not a capital I, it's a small I. Then take away this. Okay, and then compile it again. It used to work. That's my second phase of my career.
Okay.
Now the third phase is, even now sometimes there are some issues, but now I blindly type it, and most of the times it's right. Okay?
Yeah, that's true. That's true, of course, because of experience.
Okay, so
But you know, to be honest, like out of everything so far, the most that I'm actually enjoying is just the coding part is actually my most interest as far as this whole thing. Everything is very interesting, but like when I got to like lesson 14, 15, 16, 17, like the coding, the C functions and the I think converging, right? Is it conversion when you convert? That's actually really, really, really extra interesting to me.
it's like an ice cream.
It's
Girls, when they find the ice cream, right? They give that expression, wow. So chocolates and ice cream.
it's
I'm glad
it is
you
so
like.
amazing. It's like when I find the problems, every syntax has like a little problems, like it fails, and I said okay. And as soon as I figure it out, the happiness that's in me is just like crazy.
Overwhelmed.
So yeah, it overwhelmed me. So
Yeah.
that's something that
So
I'm enjoying. But anyway,
then you see you are the software engineering, I mean software IT is written all over you, Melly. You are if you are
yeah,
enjoying coding, I'm telling you the IT is
yeah.
the field for you. Honestly.
Probably, yeah, probably. I mean, I can't think like that far right now because I'm overwhelmed. Like, as you know, this is my first time doing this, and this is like crazy to me.
Right.
But I can see probably in the future I might go to that direction. It looks like I don't know. So it's fun, but I'm enjoying it for the moment.
Wonderful, wonderful.
So
I'm so glad
yes,
that you're liking the coding. So that's where I'm little worried about the other students as well. So when they get to the coding part, like how would they take it? Because that is the reason why I'm requesting other students to stay ahead of the class and
yeah,
send those recorded videos. So let's see how the other students. I'm worried about all of them, but I'm so glad that you're liking it. Okay,
yes,
that's the way to
definitely,
go.
definitely,
Yeah, that's
yes,
the way to go. And you're very, I mean, if you continue to do the projects that I'm giving you, really, so after 3 projects, your whole perspective will change. Whatever you've spoken today, now you would say that, oh, that was so easy. I didn't know why I spent so much time. Okay, when you
yeah,
get to that point, right, you're ready for the
yeah.
interviews. Okay,
That's what I want. I want like projects. I want assignments. That's what really, gonna help me practice more, Like I can only practice right now what you're doing, what you demonstrate on the videos. I do that, I duplicate that, and I am like okay with that. And sometimes I try to go a little bit beyond and just try to figure out, okay, what if I combine these two? Would it work and things like that? But like if you give us like projects and stuff like that, when you start doing that, then that's definitely going to be a more practice to me.
practice. But are you
Yeah,
are you doing the assignments? What is being taught or what is being asked for you in the classes?
yeah, you mean the scripts and stuff?
Scripts and end of the class I give an assignment, right? As a part of the class itself, I'm giving the assignments. So are you doing those as well?
Yeah, I've did all the assignments that you've given so far, if
Not in
that's what
this
you
class,
asked.
the recorded videos class.
No, that's never recorded though. You don't record the assignment parts. You cut it as soon as you finish your theory part, you cut the videos.
Oh,
There's no assignments.
sorry about that. I think there are two
Yeah.
sets of recorded videos. What I have given you is an old set. Now I send you a new set wherein there are assignments. So sorry about that,
Uh,
Billy. I never paid attention to that. So just
uh,
request for the new set of recorded videos. In that there are assignments as well.
that would be amazing. That's awesome. Yes, definitely. I like those actually. That's better.
Just request for that in an email. I'll send it across to you. Okay?
Okay, I'll do that tomorrow. Okay. All right, perfect. That's awesome. All right, thank you so much, Kumar. I really appreciate your help.
Wonderful, wonderful. Okay, so Samir,
All right.
can you put that question across to me again? Can you include GIT also for weekend classes? What do you mean by GIT? I didn't get that. Samir, what is JIT? I didn't get that. Sorry. Samir, knock knock. Buddy Samir, are you there? You there? Okay, I don't know, like, what Samir is asking for. Okay, fine. Can you include this for the weekend? Samir, you can just WhatsApp me. Okay. Samir, are you there? I'm not able to hear you, Samir. If you're trying to speak, I've seen unmuting you. I mean, muted yourself. He went offline. Okay. Okay, guys. See you tomorrow at the same time.